Yes. So Erik Brandsberg, CTO and founder of Heimdall Data. Doug, you were saying that Bank of America had created something similar for their own use. We had found that is a common story in larger infrastructures. There's some sort of data abstraction layer that many companies have internally normalized on, but it is built from scratch in everybody's environment. Okay. Everybody took the not invented here, or they couldn't find it at the time that they built it, so they built their own. But that's resulted in everybody doing things differently all over the place. And well, why not have one vendor that provides that type of service to everybody, and you aggregate together the effort and just pay for it as a product or a service and good to go. So that, in a nutshell, is what Heimdall is trying to do. So Thomas, if you wish to enable screen sharing so that I can.
Yeah.
Now, since it's such a small group, I'm basically just going to jump in to the product. No slides. Ask questions. Feel free to interact. It is certainly something that this size of a group can handle.
Which is a consultancy software company.
Okay. Hello, Joel. Nice to meet you.
Hello, nice to meet you also.
Okay. Are you guys able to see my screen now?
Yes, sir. Yep.
Okay. So what we have here is our central manager. And just to give you an idea, Heimdall is broken up into two pieces. One is the central manager that's used to control, configure, and monitor the proxies. And then our proxies are run as a separate process that allow for auto scaling and deployment on other instances. So you can manage more than one proxy through the central manager, and you can have clusters of proxies as well. So within an Amazon environment, we support auto scaling of our proxies. And in fact, we provide a CloudFormation template in order to do that right here within our documentation. So you can customize that as you need, as you desire as well. But as we've explained a little bit before, the proxies operate as a data abstraction layer between the application and the database, and provides a wide range of services for the applications. So the most commonly used feature is caching that customers use, which we'll get into in a little bit more detail in a bit. We do read-write split so that you can break your reads out to read-only nodes automatically in order to leverage secondary servers or databases within a cluster, while directing your transactions and writes to your primary writer. This often offloads a significant portion of load from your writer and allows you to either scale down your writer node to save cost, or just makes it more efficient and allows you to grow quicker, or grow your traffic load without having to scale up your writer. A large portion of our customers are in Amazon, and we do have integration features with Amazon directly. So for, as an example, within the wizard, you can come in here, you can do AWS detect, and if I had an RDS cluster actually spun up at the moment, it would allow you to select that, so for auto configuration purposes. So that makes it easy to deploy and manage within AWS. We also have integration with CloudWatch to perform or to provide metrics, so that you can be monitoring through CloudWatch both your metrics as well as your logging. Okay, but let's give a little bit of a demonstration on how these features work. We have our dashboard here, and I'm going to pin down and drill down, and I'm going to monitor this Odoo application. Are any of you familiar with Odoo as an app? It's kind of a one-size-fits-all application. It does all kinds of different functions, but the function that we are using for our demo is an e-commerce application. Okay. And we've got a workload generator that's basically spidering through this content in order to generate this traffic. So everything within Heimdall, or almost everything, is rule driven. So here's my rule list, and ignore the site unlicensed. I just need to reset things. But I'm going to enable this rule for caching. And let me edit this. That would turn off caching for some. Okay. And I'm going to go back over to the dashboard. And what we're going to see is almost immediately we've got a performance benefit. And you can see the reduction in average query response time here. So let's take a look at this. I've paused the screen. We started with a query response time of about 1 millisecond. And we were able to, through caching, make the query response time less than 200 milliseconds. Or microseconds, sorry. And the cache hit rate for this app, and believe it or not, this is not unusual, is around 90% that quickly. Okay, e-commerce apps are notorious based on what we've seen for using the database effectively for configuration parameters. So what's happening is every page view, you're getting like 9 out of 10 queries aren't unique to the actual page. It's just, what's the template? How should I look? What should go on this page? And those queries coming out of database can be cached very, very easily. Okay, so net result, huge number of online apps, e-commerce in particular, you see 75 to 90% cache hit rate is very typical. And then it was that easy. Let me again show you this rule. That's the entire configuration for all the caching to be enabled. Okay. We have enough logic internally where without you specifying it, we are aware when you do writes against tables, we invalidate cached objects that are in that table. So this 5-minute TTL, that's a maximum time. If we determine a condition has occurred that should invalidate that content, we do it automatically. We're aware of things like select for update, and we treat that as if it were a DML, and we send it to the writable server. So we're syntax aware for most of the databases, and we handle all this cleanly. Any questions on that? Got to have some questions because everybody thinks that the caching is black magic.
Well,
yes.
I'm just curious if you're running, when you talk about configuration in the database, does that apply, or would you consider it to apply to WordPress websites that are built for e-commerce, or is that out of scope for what you're doing? Because I just asked because there's so many websites that are built on WordPress, and it by default is using MySQL.
Here is a demo that we have running through Heimdall right now.
Okay.
Using the Woo Shop plugin. Okay. And if we go over here, dashboard, WordPress, you can see the traffic that I just generated. Okay. So very quickly got up to an 80% cache hit rate right there. Not too bad. Okay. And then we also have another common e-commerce platform, Magento. And I need to turn on Magento rules for caching right there. Let me click through a couple pages. And it's not quite as high here, but if I continued, it would warm up and it would get up there as well. Okay, so these are all very common out of the box packages that we just run with. Someone had a question?
Yeah, if you could explain why why is it that the databases, how is the caching different or better than the underlying databases, which presumably many have caching mechanisms themselves?
We augment it. Well, let's talk about a couple. Okay, let's talk very specific examples. Let's start with MySQL. MySQL 8 has deprecated the query cache because it doesn't scale.
Mm-hmm.
Okay, Aurora, while a variant of MySQL, it does have a query cache, but it's a block level cache.
Mm-hmm.
And well, actually, you have a block level cache and you do have a query cache on Aurora. But what we found is that by using us, you're effectively dedicating cache resources, and that frees up resources for other caching that happens on the database side. So effectively, it's additive in order to improve performance. In addition, you can dedicate resources to a cache, and often that's going to be a bit cheaper than trying to use the database itself as a cache. So it's a cheaper resource for you. Now, the way that Heimdall works is that we actually operate as an L1 and L2 cache. So you run Heimdall, say, on an instance or a Docker container or something like that. You can size and scale that instance separately from the database. So when I'm talking about auto scaling, it's much easier to auto scale Heimdall based on workload and caching load than it is to spin up and down different instance sizes of your database. Usually the database is going to end up being a fixed size. You want to push as much workload onto the resource that you can automatically adjust the size of based on workload.
Yeah.
Okay, so that right there is a great reason to leverage Heimdall as a cache as opposed to just depending on the database to do it itself. Okay, we also have a lot more flexibility and controls. And then we can leverage read-write servers, and you can think of a read-write or a readable only server as if it is a cache itself for the database as well.
Yeah, I mean, to what extent is it reproducing the structure of the data?
It's not. We are a result set cache. Now we do have two modes of operation. We can operate as a JDBC driver, or we can operate as a proxy. Depending on which mode you're operating in, it does handle the cache a little bit differently. When operating as a JDBC driver, it effectively becomes part of the application, and we store the result set as a Java result set, which means we simply hand off the result set to the upstream application, and it can use that result set, and it doesn't have to do any additional parsing of the data. And it's the serialization and deserialization of the result that actually adds quite a bit of load when dealing with the database. In proxy mode, we store the result as a byte stream that represents the data. So when we have a cache hit, we literally just dump the byte stream onto the wire and we're done. And it's actually very, very efficient. Whereas even with a database level cache, often it still does the serialization to put it on the wire. Okay, it's just a matter of how we've done that.
And the key in this case is the select statement, basically just a string.
The key, it is the query.
It's the results of the string.
Well, the key is the query. The result set is what you get from the query. But the key also contains other information, and some of that is configurable.
Key, I thought you meant key,
Yeah. Okay, if you look here, customize query cache key. So it by default will include the select, but it also includes the VDB name that you're accessing, the JDBC user or the actual database user that's connecting, as well as the catalog, because all of these can be considered to be unique constraints on what can be delivered to as part of the result. So these help to ensure that it's unique, but in some cases, you don't want, for example, the user to be part of that key, so that you can now share cache between multiple users. Okay, or I can't think of many situations why you want the DB catalog, but you can turn that off as well. Okay, but these are all included by default. Okay.
How do you handle cache coherence, especially if you're doing it at the JDBC level?
Okay, great question. And again, there's some variables that come into play. In general, let's say you're using Redis as your cache. And you have, so Redis not only operates as a cache layer, but it's lesser known, it provides a pub sub interface. And all the caches that we support provide pub subs. What this allows you to do is basically before we allow a DML to go through to the database, we send out a pub sub message to all the other nodes saying DML is about to start happening on this table on this database. So that results in a cache invalidation message being sent out that when received by the other nodes, what will happen is they will know to not serve anything from the cache or actually use the cache at all for the next 2 seconds for that table, but that table alone. So it is at the table level of granularity. If the DML has not completed, or you're in a transaction when you do that DML, until the DML completes or commits, every second we will send out another cache suppression message, the invalidation, to keep a window of time open for invalidation. We know that stuff is happening on this table, and it's a sliding window. As you go along, every second we refresh that window until everything completes. So as a result of this, for any given table, you will reasonably see only one message sent over that pub sub interface while DML is happening to it. That allows you to scale to having huge numbers of DMLs against a large number of tables, and you're not going to overwhelm your pub sub interface. Okay, and it allows latency to remain very low. So basically, every time a DML happens, it will inherently trigger no caching on that table for at least a 2-second window, and that will be shared as state across all the proxies when you have more than one. Any other questions?
So assuming a change is made, is it, how intelligent is the cache invalidation? Meaning, you know, if I add a record to the table, that probably would be okay. If I update a record, but my cached result has nothing to do with that record, or is it just like anything on this table, we're going to wipe that query? And
it's at the table level. Any DML against the table by default will invalidate everything associated with that table, including if you had joins on that table.
Cool.
Okay.
Okay. Sorry, and maybe you mentioned it earlier, but what databases do you work with?
MySQL, SQL Server, Postgres as proxies, and then anything basically with a JDBC driver when used in a Java app. So we have people supporting using DB2, Oracle, etc. Okay.
Yep. Thanks.
Cool. Okay. So now that invalidation logic that I just went into, that's a natural extension into read-write split, because we actually built read-write split on top of our cache logic. And you would think, well, all you need to do is know if it's a read or a write, correct? Well, not really. You need to know what table is involved and when the last time you wrote to a table. Because if you wrote to a table within, say, 1 millisecond ago, and then you do a read against that table, you need to know that, because the only safe place to do the read for that table is on the writer, because it hasn't had time to synchronize yet. But if you're reading from a reference table, say a configuration table for the template for Magento, it doesn't matter how long you wrote to the sales history, you can always read that from the reader. The only other products on the market that we know of that attempt to do automatic read-write split are doing it at a global level on knowing how long it takes replication to lag and knowing that reads or writes were done, or not even that. They just say, well, if the replication lag is lower than a certain amount, they consider it safe to use the reader. Okay, so that means that you don't get read after write consistency. Okay, Heimdall gives you read after write consistency, yet still leverages the reader for all the stuff that doesn't change often. So it's the best of both worlds. You get consistency and performance and offload. Okay. And it was kind of interesting, the read-write split, because we had worked so much on making the caching work so well, including the invalidation windows and everything else. It almost came for free. Okay, but it does allow us to, for example, read from the read-only database when a read contains a timestamp that, say, is down to the second, and a lot of queries end up fitting that pattern. They are not cacheable, but you can pull from the reader safely. Okay?
Yep.
Okay. Any questions on all that? Because to a lot of people trying to do stuff like this, it is black magic. They just don't believe that it works.
It seems quite sophisticated, so
Okay.
yeah.
Another tidbit, another piece of how we operate internally is when we do caching to something like Redis, because you can enable query caching to Redis instead of local. Okay. The way that we operate with Redis is we leverage, and Redis, and actually any of the other caches, they support this as well. They have a feature called key tracking, where they can generate a message on their pub sub interface when something happens to a key within their cache. So if you delete a key or you add a new key, they can notify through the pub sub saying, hey, here it is now. Well, Heimdall keeps track of all the keys via that interface to know what is there and what is not there. So instead of asking Redis, do you have something, only to get an answer of no, we only ask Redis when we know the answer is going to be yes. So the net result of that is that we lower the workload significantly on Redis. All it has to do is tell us these keys exist. And anything that's not in Redis, we don't bother with Redis on. And the important thing here is that when trying to use caching for performance improvement, the fewer round trips you deal with, the better. And if you add a round trip on every cache miss, just to say it wasn't there, then you can negate the performance improvement that caching gives you to begin with. Or it only works if you have very high cache hit rates. We can give a performance improvement even if you have very low cache hit rates. Okay, so that's one of those neat little optimizations that we've done, that when we mention to programmers, they're usually like, ooh, didn't know that we could do that. But
Are you
it,
oh, sorry to interrupt. I was gonna say, are you doing something similar with Hazelcast?
yes.
Yeah.
Yes. So all the caches that we have, that we provide support for, include key tracking and the pub sub interface for invalidation. Otherwise, we don't want to deal with it. So when we first started, we were like, oh, we want to use memcache. Well, memcache is a good cache, but that's it. Okay, it doesn't unless it got added in the last year or so, because I haven't even bothered looking at it since then. It didn't have a pub sub interface. It didn't have these advanced functions that we generally need. Now, what if you don't want to deploy out Redis because you're trying to save money? And who is not trying to save money with the whole financial situation that's going on in the world right now? Okay. We do have, in the case of Postgres, Postgres has an option of using a Postgres has built in a pub sub interface on its own. Okay, and it's the only database that we know of that has this built in, that you don't have to do anything to leverage. So if you do this, then what you can do is you can set your cache just to be local. It'll use local heap to store the objects, but it will use the Postgres pub sub or notify interface, as they call it, in order to do the invalidation logic for the invalidation windows. So in the case of a Postgres environment, you don't even need a separate cache layer. Okay. There are some benefits even on top of this that the cache layer provides. For example, it gives you a cold store so that if you start up a new proxy instance, then it's not going to pummel the database in order to pull data in that's hot. It'll just pull it from the cache layer instead. But often the benefits we get can be realized by caching even a couple seconds worth of data. So often that's not even necessarily enough to justify the cost. Okay, so Postgres really is a nice database as far as this is concerned, because it allows you to make your configuration even simpler than the other databases do.
When you do a deployment using Hazelcast and you need to scale it out, are the nodes scaling in tandem with the number of instances of Heimdall, or is it separated?
Yes. Any other questions? It could be either or. Okay, it depends on how you configure your Hazelcast. For those that aren't familiar with Hazelcast, it is Java-based as well. It can operate as a peer-to-peer environment where each application has the client libraries and they all talk to each other, and it allows you to effectively share the heap on all your application server nodes as a unified cache. You can alternatively deploy it where each client is just a client and it is connecting to a set of nodes that act as a cache. So you can use it either as a hub and spoke or a full mesh peer-to-peer. And that does make it nice and flexible. Although in the case of AWS, for example, you have to do some additional configuration to allow Hazelcast to auto-discover its nodes. Okay. But we support both models. I will say most customers just use Redis because as a managed service, most clouds provide it. And there it is. It's done. Okay.
Yeah, very good.
Okay. So read-write split and caching are really the two biggest features. As far as the read-write split, We have configuration where you basically specify each node as being whether it's writable or not. You can set weight for load balancing of nodes and such. We also have this track cluster changes. And that adds logic in that will attempt to track the state of the servers in the cluster and will auto reconfigure itself based on the state of the cluster. Now in Amazon, any of you have customers or doing deployments in Amazon with RDS or Aurora?
Yes.
Okay.
Definitely.
Yes.
Not Doug, it appears. Okay. Within Aurora, it has the concept of a reader URL and a writer URL. The writer URL obviously always points to the writer, but changes to those URLs can take up to 5 seconds to propagate. Okay? Because it's done via DNS. It's not an endpoint that actually operates via load balancer that can nearly instantaneously change and redirect itself. Doug, you looked a little pained. Do you have any comments on why DNS would be so bad?
No, a friend of mine could go on for hours on why DNS is bad, and I refuse to be him.
Okay. Well, we determined it was bad as well. I'm going to go into some details. I mean, this is more not just about promoting our product, but trying to explain some of the things that we've done because it may apply to your lives as well. With Aurora, let's talk about Aurora MySQL because that one's where it's really bad. Let's say you connect to the database that is the writer at a particular moment. You're doing a whole bunch of stuff. You've got a connection pool for your library. Everything's good. Well, someone, for whatever reason, chooses to do a failover so that the writer becomes a reader and a reader becomes a writer. Okay? Now, what do you think happens to the connection that is already established to the writer?
Terminated.
Nope. Nothing. It simply stops allowing you to do writes.
Yeah, it doesn't sound good.
This is one of those little gotchas that most people aren't aware of. Okay, Postgres will terminate the connection. MySQL does not. So if you haven't added logic in your application to detect, oh, I just tried to do a write and I can't do a write anymore, I need to reconnect, well, you're going to have a problem because that application's not going to work until you restart it.
That is absent of, that is default behavior right now. So if I had a web app running that's reading and writing to a MySQL database, and it does that swap that you're talking about, I've got a problem. I need to bounce my app.
Yep.
Okay.
Okay. Now, if you're doing something like PHP, that's not so much of a problem because it's opening and closing connections pretty much with every page view and such. And as soon as DNS, the 5-second DNS cache updates, it's going to connect to the correct one and you're fine. But if you're using like Java apps that inherently are using connection pools and such, this becomes a much bigger issue. Okay. Heimdall will detect that condition and can reconnect to the new one. And more to the point, we don't have to wait for the 5-second TTL to happen. We actually are AWS API aware. As long as you give us proper permissions, we will ask AWS via the API, what is the current state of this cluster? Period. And we get the entire cluster state, not just a 5-second cached DNS entry. So we know what nodes at that moment are the writer, we know at that moment all the readers, and we can reconfigure ourselves accordingly. And we send the traffic not to the DNS name, but to the actual endpoint specifier for each individual node. This is very important if you have more than one reader. We have one customer, okay, you guys are gonna be like almost horrified with the bill they must have. We have one customer that has 15 R5 12 extra large readers for one cluster.
That's a lot.
Okay.
That's massive.
Do you know how much their bill is, their RDS bill every month?
100 grand?
It's definitely over 50 just for that one cluster. Okay. They're probably going to be able to reduce that size fairly soon. The reason why they had to have they had so many is because RDS itself was not, because they were using the reader endpoint to handle the load distribution. Well, the application was only periodically opening up new connections and closing connections. And the reader only resolves to one IP address at a time. It was not doing DNS round robin where it would serve all 15 addresses to the application in random order every time it was asked. It only sends one DNS entry or one address record. So the application has no idea that it can open up connections to more than one database at any given time. So this resulted in some database nodes getting over twice as much traffic than other nodes at any given moment. And it would fluctuate over time. So with Heimdall doing the load distribution, it being aware of all the nodes at any given moment, it can open up connections to all of them in order to share the load more evenly. So the net result is you can share the load across fewer nodes and run much closer to maximum capacity without any impact on behavior. Okay, so that's just one of those things that we've done that make us operate better than other solutions. Even if most of the people tried to hard code it, you have to go a lot further than just doing read-write split. You have to figure out how to balance the reads across many nodes as well. And in an RDS environment, that's not all that easy. Okay.
And so, sorry, forgive me on this, if I recall correctly, I need to change the URL to use the read replicas in an RDS environment, if I recall correctly.
But we bypass that.
You bypass that, okay.
Okay, we actually use the endpoints for the individual nodes to target our traffic, not the reader endpoint.
Okay, and then
okay.
you're effectively acting as the load balancer there.
We are, correct.
Yeah, okay.
Okay, because that reader endpoint is not load balancing anything. Okay, it's just giving you a random IP within that set of readers that, oh, by the way, gets cached for 5 seconds.
Okay.
So you only see one reader database at any moment for 5 seconds, or for a 5-second period.
Okay.
Anybody else have any other questions on that? No?
I know that you had mentioned that you work on AWS. Are you exploring, or have you worked, or have you this product deployed on like Google Cloud or Azure? Or
we have a marketplace offering on Azure as well.
Yeah.
And we are looking to get onto the equivalent Google marketplace. But we've had so few customers asking for it, and we can simply deploy out as a standalone instance. Or as a self-managed instance for any other environment as well.
Okay.
Okay. But the reality is, so many people are in Amazon compared to the rest that it's been our primary focus. Azure it's a distant second based on our interactions with them. And GCP, I think we have one customer that's in GCP right now. So,
Okay.
a couple of things. Are all of you independent people at this point, or what's your roles?
I'm a co-founder of a tiny company. We have some work going on right now at a division of the U.S. government, and I do contract work myself. So total, we have 3 people in the business, 2 of which are machine learning / statistics / software experts, and then in my capacity, I'm a software engineer.
And everybody else, just for context, because I want to see what I need to, some topics that I wanted to leverage. Doug, are you like a consultant or?
I know, I work for, well, a government contractor, I guess, that does like municipalities, local county tax collection largely.
Okay. Daniel?
I do contract work. I'm not on anything right now, so.
Got it. Okay. Oh, since it was mentioned, we are in GovCloud. So we are available to be spun up on the marketplace for GovCloud offerings. We are, although it doesn't sound like anybody is doing any military work or intelligence work, we are working towards being put into the Intel siloed Amazon setup as well. So that takes a lot more effort to get into. As far as just at a high level, talking about the clouds, we have found that working with Amazon has been a much more fulfilling environment than any of the others. They seem to be much freer with providing credits for various programs. As an ISV, they've been very supportive to us. They've got separate programs for certifying for different products. In particular, Redshift and RDS have like Redshift Ready and RDS Ready programs where you have to go through a specific certification process within the business unit to get the designation. And Heimdall is quite possibly the smallest company that is Redshift and RDS ready, or Redshift or RDS ready, I should say. But they've been working very well with us. If you ever have an opportunity to generate blog content for the Amazon blogs, do it. Okay. Those are, from a search engine perspective, they get linked very, very highly, and it helps your credibility enormously. We've gotten a lot of referrals just by the fact that we are hosted on the Amazon blogs, and it's published content showing up under the Amazon banner. Okay, so it's great from a credibility perspective. Anybody else know about IQ aside from Thomas? Amazon IQ? Okay. It's something that is, I think, more of a future benefit. Thomas, have you had much business from IQ yet?
No, I've had 1 or 2 leads. I think at the level that I'm at, I'm kind of not seeing very much of the really good leads that come through IQ.
Okay.
Once in a while, there's something interesting there, but a lot of it turns out to be kind of noise. But the leads that I've had have been interesting.
Okay. IQ is a service that Amazon certified engineers can sign up for. And basically, it's kind of like Upwork or other systems in order to direct consulting work to consultants. Now, we signed up for, or I signed up for it to try to be able to possibly provide, to see what type of database opportunities may be out there, people looking for help on databases. And I haven't actually been active in handling work requests myself. But the other benefit that I've seen is that everybody that gets invited into IQ gets invited into a Slack workspace with all the other IQ consultants. And that area is actually how I met Tom. And I think that it's definitely a place to bounce ideas around, to ask for advice, etc., for anything dealing with Amazon. So if you're AWS certified or can be certified as soon as they start doing certifications again, given the whole not being able to sit down and take standardized tests at a test center right now, I would recommend doing that, if only to get on that Slack workspace, to get invited in, and use that as a resource. So
I think the Slack workspace is very helpful. I mean, just for meeting people that are highly technical, it's been very good.
yeah, I mean, just that association. I set up a LinkedIn channel where people could post their LinkedIn link in order to build up their professional community via LinkedIn as well. So just post it and everybody else can click and accept, or you can send out to everybody else that's posted in there as well. So
I do, Eric, you may know the answer to this. I'm not sure. I think I read somewhere that depending on the tier of partner you are with Amazon will determine the level of quality of leads that you get on IQ. I think that I heard that somewhere.
I'm not sure if it's the tier, it's how many you actually reply to.
Oh, I see.
It's your activity level. So the people that are more active in providing responses and more active in working with the customers get a better shot at the leads.
Yeah, that's interesting. Okay, thank you for that.
Okay. So hopefully that little tidbit is useful to someone on the call.
It's useful to me, so thank you.
No problem.
Yeah, it's good to know.
So we've got a few more minutes left. Any questions? Anything else? I mean, even broader topics like how it's
Eric,
been. Yeah, go ahead.
Can you talk about your security and just kind of what level of security you either add or don't add to both kind of proxy scenario and JDBC scenario?
Okay. We support terminating database connections using TLS 1.2. Through the JDBC driver on the back end that we use to connect to the database, those generally support TLS as well. So we can be fully encrypted on the wire. We support additional layers of configuration where you can configure rules on a per user basis. Let me drill into this for just a moment. Let's go into here, proxy configuration. We have a variety of different ways that we can do configuration. Let's say we wanted to do Active Directory. Well, we can take Active Directory, a login that someone is trying to make, their user and password. We can authenticate against the LDAP or LDAP-S server. We can then do group extraction with filtering. Then, as long as the user has extracted at least one group, then we can synchronize the user's credentials into the database, including role membership, say for Postgres, based on their LDAP group. So this allows you to control table and other accesses effectively at the Active Directory level, but enforced at the database level with no additional configuration needed. And we will synchronize those credentials even after a password change, caching the data for no more than 5 minutes. Okay, so the way that this works, if you go into our documentation, theory, password authentication, database synchronization, when we receive the credentials and they've been accepted through Active Directory, we will call a sync user function with those parameters using a privileged user. And then this is an example sync user for Postgres that will ensure that the user and group are created and that the user's authentication is in sync with what Active Directory accepted. Okay. We have this functionality. It was primarily targeted for a large computer vendor with a name that is 4 letters long, that has a very large Greenplum cluster with over 2,000 CPU cores within the database cluster that they're using as a data lake. And they have thousands of users that are able to log in, and they wanted to manage everything through Active Directory. Any other questions on that?
Nope.
Okay, sound useful?
Yeah. Is this mostly written in Java, or are you able to say?
Heimdall is completely written in Java.
Okay.
Okay. We wanted it to be portable, and it's fulfilled that need in spades. We support not only Intel architectures, but we run and test on ARM as well. I'm not sure for any of you that are in Amazon. Amazon just released something called the M6g Instance Types. And these are ARM processor-based instances that actually, on a price performance perspective, compete very, very well with the Intel systems. You can save potentially 20 to 40% by using these ARM instances over the comparable Intel instances. And one of the reasons why they do so well is because you're not actually being charged for hyper-threaded cores. It doesn't do hyper-threading. A vCPU is actually a core, not a thread on a core. Okay, so an individual thread will run about about 70 to 75% of the speed on a comparable Intel core. But once you add the second core in, and you're doing 2 threads, the aggregated amount of work that they can do will be more work than 2 cores on an Intel can. But you get charged for less.
Okay. And then I guess the reason for that is, if I can phrase it like this, the 2 threads on the one, what's it called, ARM? M6? Yeah, those are dedicated, juxtaposed with, yeah.
Right, so you get a full CPU worth of capacity for every core you buy. Whereas if you're using 2 cores on an Intel, they're competing for the CPU resources. And you can only get but so much out of 1 core. And the more optimized the code is, the tighter it runs, the less you're going to get out of the second core. If you've got lots of weights waiting for memory, et cetera, then hyper-threading is fine. But for server workloads, it actually works very nicely to use the ARM. And that derived from the question of what are we written in? But, any other questions?
I don't know if you went over it before, just quick high level pricing.
Easiest way to look at it is look on the AWS Marketplace, because it does have pricing right there. Okay.
Okay, sounds good.
Yeah, and for people that are doing higher volume or are price sensitive, within Amazon, there's something called private offers. You can start off using the pricing that is on the price sheet on Amazon. But we can provide a private offer that either modifies the terms of, say, support for people, or the price for a customer. So let's say you had a customer that is a nonprofit that has something that we really want to support. You could just go through the pricing on the marketplace, and Heimdall can offer a significantly discounted price to that customer, much like a reserve type of pricing, although there's not necessarily a commitment involved. So, and that also allows us to price on a per hour basis with auto scaling groups, et cetera. And it makes it a lot easier to handle the billing. I mean, the AWS Marketplace billing has been a godsend for us, because we literally have customers we don't even know who they are, and we're getting money from them. So, anything else?
Any interesting new features that you're going to put out in the near future?
I can't say a lot. It's just a lot of refinement. I mean, the amount of functionality that we have at this point, I mean, I haven't even drilled into like half of it. Let me pull down the rule list just to give you like the 2-minute rundown. Allow, as well as and learn pattern, and are used as part of a built-in SQL firewall function that we have. So we can learn the query patterns that are going through, building a list of regular expressions that are handled that we optimally deal with. And then we can block or notify people when there are new patterns observed. Caching, fine. Call just makes for, you can do nested rule lists if you want. Drop, you can drop functions. Extract plan is to give you query plan visibility. I'll give you a quick demo on this, because this is kind of a nice little feature, so that you can do post-mortem analysis on why is a particular query slow without necessarily having to dig into the database and ask for it. Just give it a moment. There's a lot of data analyzing. Anytime now. There we go. So, oh, I have, that one's disabled for the query plan. Let me do this one. Hopefully this will go a little bit faster. But this allows you to basically keep track of the query plans, and this gives you visibility. Say if you wanted to, you could give your developers access to read-only access to the Heimdall GUI, so that they can see what is going on in production, but they can't change anything. Okay, and then we can click here, and then you can see that this is a MySQL query plan. And tells you, shows you the formatted query, a little bit easier to read, etc. To go back to the rules. So you've got the extract plan. Forwarding, you can actually explicitly forward queries from one database to an alternate database of the same type. So you can create multiple sources and reroute queries, say for a particular table, onto a completely separate database.
That's
okay.
Interesting.
No cache, you can build to create exclusion rules for your caching. Reader eligible is for the read-write split. Result, you can actually create a result manually in order to return back, used for a couple of corner cases. Retry is interesting. It allows you to create an automated retry on various exceptions. An example of when you would want to do that is if you're using a Galera cluster and you try writing to a table that's been locked by another cluster member, then it can give a deadlock exception, and it simply tells you retry again later. Well, this allows you to do the retry automatically. Okay, or this can be used as part of some failover logic in order to deal with a query that was not completed as a result of a failover, etc. Stack trace, just more for debugging. Transform, you can actually rewrite queries on the fly. So let's say you have a query that was poorly written that did not include a limit 1000. Okay, and someone's trying to return select star from a big table. Well, you can throw the limit 1000 on it if that's what you want, or an appropriate order by. We primarily look at this transformation as kind of a quick hack patch mechanism so that you don't have to redeploy applications when you realize that there's a problem. Or you can fix it while waiting for a redeployment or a patch to be deployed, say, during a normal maintenance window. Okay, and trigger. Now, this is an interesting one. This allows you to trigger an action when a particular query is observed. Now, this trigger could either be another SQL query that is executed, or it could be execution of a script that you put on your central manager when something happens. Now, with a SQL, you can say before the query that is triggering the query, this trigger, execute a SQL command before it. Okay, or you can trigger something after. Let's say you wanted to clean something up. Okay, you can also add parameters on here to timing. Wait, timing's that queue unique. Okay, only allow one to be executing in parallel at a time. Or you could do max delay. Okay, you can add in another here, delay, only do the execution after a certain amount of time. And this can be queued up with the unique. So after you see something happen, wait up to 5 seconds and then trigger the SQL that may say do a query. But if another one comes in, then it can keep delaying the execution until a maximum time has been elapsed. Now, this is interesting because it allows you to do things like a commit after, say, 10 seconds worth of inserts were loaded in by an ETL process. So you can trigger it to do commits on a periodic basis while the data is actually loading. You can use this to actually create a dynamic command that inserts the select that was performed into a log that is sourced on a completely different database. So you now have an audit record of every select that went through your system on an alternate database to create an audit log of selects if you want, without impacting the performance of your actual primary operational database. Because you don't have to turn audit logging on your production database. It's putting load on another database. So there's actually an awful lot of functionality that you can do using this trigger functionality. And the the limit is your creativity.
That's cool.
Okay. Yeah. And one final thing I didn't even mention, Async Execute. This allows you to take a series of SQL commands that are happening, extract them from the execution stream to the database, push them onto another asynchronous thread, and execute them there. Now, have any of you worked with Redshift before?
No.
Okay. Greenplum, any analytics databases? Okay. Let me explain the use case a little bit then. Greenplum and Redshift are massively parallel database systems. So like in the case of the 4-letter computer vendor, they have a cluster that has 2,000 cores spread out across 96 core systems. The way that Greenplum typically wants to receive data is in large batches that each individual node within the database can pull in a chunk of the data and ingest it individually. And you have many nodes that are all doing that work. What they don't like are singleton DMLs, where you're just saying, insert this row, because there's an awful lot of overhead involved in that when it has to do that type of work. Redshift's even worse. If you do a benchmarking on Redshift, often if you did just insert row, insert row, insert row in auto commit mode, you're going to get about 8 inserts a second. That's it. Okay. What this async execute allows you to do is if you have a scenario where you've got an application trying to do singleton DML, you can absorb those DML commands, spoof a result saying, yes, it happened, go away, we're done, very, very quickly. We batch it up, put it into a transaction, or even rewrite the DML so that instead of it being 1,000 insert 1 row commands, it becomes a 1 insert of 1,000 rows. And Redshift will absorb that 1,000 row command just as fast as it'll absorb a single row command. So you batch it up to a size of 1,000 and you've improved your write performance by a factor of 1,000.
That's pretty neat.
Okay, all without code changes.
Pretty awesome.
Yeah. Greenplum isn't as bad about DML performance as Redshift is. Redshift is just a hog. Okay, every DML that you do is going to result in at least a 1 megabyte buffer being written, because that's its block size for writes. Okay, so you want to fill a 1 megabyte buffer on every write. Okay, and we've got various controls on how long we should wait. We can, if you've got lots of threads coming in, we can actually set it up where we can absorb 1 query per connection. But we aggregate what all those connections are doing into 1 batch. We wait until the batch is committed before replying back to all those threads at the same time. Okay, or we can spoof the result saying, hey, yes, 1 result was returned or 1 row is modified. Okay, and just be on our way and assume that we're going to report the error if there's a log, because we have an error log that you can follow up on later. If there's an error, then it'll be handled there. Okay, so there's a lot of functionality here. We really are a jack of all trades. If there's anything that you can think of that is useful to do between an application and database, we've probably implemented it.
Yeah, it sounds like you've covered quite a few use cases, corner cases.
That trigger functionality really is one of the more interesting pieces. You can do a lot with it. Okay, I think we've run over a little bit, but
Oh, good. Thank you.
any other questions, comments, suggestions?
I don't. If I come up with anything, I'll ping you on Slack.
On IQ, the IQ workspace.
Yeah.
Yeah.
All right.
Good.
Okay. Well, thank you, everybody, and hopefully you got something out of this. And if there are any use cases where you can use this, just let us know.
Will
Sure.
do. I appreciate you taking the time to show us the Heimdall Data solution. Really helpful.
Yeah.
Very good. Okay. Well, you guys have a good holiday weekend.
You too. Have
Yes,
a good weekend.
you too.
Thanks everybody
Stay
for
healthy.
attending.
Stay
you
healthy.
later.
Bye.
Bye-bye.
Yeah. Bye.
Bye-bye. See ya.